Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing polynomial division. So we're going to talk about polynomial division in this section. And one of the first things we need to talk about before we go any further about how to actually divide is a theorem called the division algorithm. Okay, and this works for numbers as well, for just integers as well as it does polynomials. But basically, if we call p of x our polynomial, basically what we're dividing into, and d our denominator, or basically our divisor, another way of thinking about it, we'll call q the quotient and r of x the remainder, then we can look at a polynomial divided by the divisor, p of x over d of x, as equal to q of x plus, so whatever we get as our quotient, we can say this divided by this equals the quotient, plus the remainder over the divisor. And again, this idea remains for, so if you call p the dividend, you could also think about it in terms of integers. Also, if you multiplied every term by the divisor, the d of x would cancel here, and you'd actually be left with the polynomial can be written as the quotient times the divisor plus the remainder. And this idea, both of these ideas are important. All right, so polynomial division, so now that we've talked about this, polynomial division mimics long division performed with real numbers. Okay, and we're going to do a side-by-side comparison to actually see this. Okay, so we have, if we do 3, if we divide 3 into 425, what would we do? Well, we first would write it like this, 3, and then we would make this symbol, 425. And we'd start by asking ourselves, how many whole times does 3 go into 4? 3 goes into 4 one whole time, so we divide, we then multiply 1 times 3, and then we subtract. So we subtract this 3 from this digit. So divide digit-wise, see how many whole times it goes in, multiply, subtract, and then 4 minus 3 is 1, and then we bring down. So the 2 and the 5. Now 3 didn't divide into 4, or 3 divided into 4 only once, so now we can't divide into 1, but we can divide into 12. So we ask ourselves, how many whole times does 3 divide into 12? And the answer to that is 4. So 3 goes into 12 4 whole times. So we then repeat the same. Divide, multiply, 4 times 3 is 12. Subtract, so 12 from these two digits. That leaves us with nothing here. These cancel, but the 5 comes down. And we can start the process over. How many times does 3 go into 5 whole times? 1 time. Multiply, 1 times 3 is 3. Subtract, 5 minus 3 is 2. Now does 3 go into 2? It does not. So what we say, sort of classically, is that we have a remainder of 2. And we can rewrite this as using this up here, the polynomial, so instead we think about our dividend over our divisor. Our dividend is 425. So we can think about this as 425 divided by 3 can be rewritten as the quotient plus the remainder over the divisor. The quotient is what's up here, the 141. So 425 divided by 3 equals 141 plus the remainder, which in this case is 2, divided by the divisor, which is 3. All right, and this is our answer. What is 425 divided by 3? It's 141 plus 2/3. All right, so we can perform this, again, almost in a one-to-one fashion, this type of division for polynomials. Now, it's not quite the same, but again, the x squared plus 4x plus 3 is our dividend. X squared plus 4x plus 3. We're dividing this by x plus 1. And we go through and we ask ourselves the same question, but this time, instead of each digit, we're talking about terms. And here, since here we only had this one, here we have 2 terms, we'd ask ourselves in a similar fashion. Here we'd add 4 divided by 3. Here we're going to look at x squared, the leading term, dividing by the leading term here. So what is x squared divided by x? And that answer is x. And we put that up here. So x squared divided by x is x. That's what we put. So we divide. What was the next step we did? We multiplied. So x times x is x squared. X times 1 is x. So we divided, we multiplied, and then we subtracted. Here, since we have 2 terms, we're subtracting. That means we're changing the sign of each of these terms. So minus, minus. And you know you've gone about this correctly if x squared and the minus x squared if you get a cancellation. Okay? And they should be the opposite signs if you did that correctly. Don't forget to also change this sign. So we have, so we divided, multiplied, we subtracted, and now we're combining. X squared's canceled. What is 4x minus x? It is 3x. And then the next step that we did after we did the subtraction, we brought the rest down. So we're going to bring down the only thing that's left here is 3. So plus 3. And we start again. We ask ourselves the same question. What is 3x divided by, so leading term divided by leading term. So now it's a wash, rinse, repeat. What is 3x divided by 3? Or 3x divided by x, I'm sorry. And the answer is 3. So plus 3. So that's our next part. So divide, multiply. 3 times x is 3x. 3 times 1 is 3. So divide, multiply, and then subtract. So we're subtracting this. And then bring down. 3x minus 3x. Again, we know we did it correctly if this cancels. But this next part doesn't necessarily have to cancel, but in this case, it does. So what is our remainder? Our remainder is 0. So what is x squared plus 4x plus 3, x squared plus 4x plus 3, divided by x plus 1? Well, it is the quotient, which is x plus 3, plus 0, the remainder, over the divisor, over x plus 1. Now, anything divided by 0 divided by anything, rather, is 0, other than 0 itself, which is undefined. So this goes away. So this means if you had 0 remainder with numbers, what did that mean? It means that what you divided by went into it sort of evenly, which means that there's no remainder. Further, if we divide by that, so looking as a comparison of just numbers, what is 8 divided by 2? Well, we know that's 4. And what's true? 8, so what are 2 factors of 8? Well, we know 4 is a factor. Since 2 went into it evenly, we also know 2 is a factor. 8 is 4 times 2. So whatever you get for the quotient, if it divides into it evenly with no remainder, the quotient is a factor, as is the divisor. So that means that x plus 3 and x plus 1 are both factors of the polynomial x squared plus 4x plus 3, which we know from just factoring it out normally. So this is x plus 1 times x plus 3. 2 numbers that multiply. So 2 numbers that multiply to be x squared, that multiply to be 3, that add to be 4, are 1 and 3. All right? So this is the answer. Just wanted to further expound upon that. So what did we do? As a reminder, these are the full steps for dividing one polynomial into another. Organize each polynomial in descending order. That's how all of these went when we organized them up here, or how this one was. Then divide leading term into leading term. And write out the quotient on the top line. Then you multiply and then subtract. Okay? And then basically just rinse and repeat until, and this is the important part, we knew we could stop at 0 because what is the degree of any constant? The degree of any constant is 0 versus the degree of x is degree 1. Here it was degree 2. So whenever the degree of what we have left is bigger than or equal to, so if this was, so here this was degree 1, this was degree 1, we could continue. So we continue dividing until the degree here is strictly, from what we have left over, is strictly smaller than that. All right, that concludes this lecture.